Literal equations and formulas. And let's start off with what is a literal equation. A formula is a type of literal equation because it contains more than one variable. So here's some common formulas that we use a lot in math. A equals b times h, the area of a rectangle. Area of a triangle, 1/2 base times height. Distance, rate, and time. Distance equals rate times time, or d equals rt. And the simple interest formula, I equals prt. And we can use equation properties to change these formulas to better meet different situations. Meaning we can use our equation rules where we're allowed to add, subtract, multiply, or divide any amount we want to either side of the equation. As long as we're consistent and do it to both sides of the equation, it remains equal. So let's look at the simple interest formula. We have the equation I equals P times R times T is used to determine the simple interest I earned on money invested P at a certain rate R for a certain period of time T. And our rates are normally given as a decimal and time is in years. So we want to solve this equation for R. So if I have I equals PRT, I would ask myself, what's on the same side of the equal sign with the R? Well, P and T are both on the same side with the R, and they're being multiplied by R. So to undo multiplying R by P and T, I would do the inverse operation, which would be dividing by P and T. So I want to divide PT on the left side, divide PT on the right side. Then my common factors will cancel out and get R by itself. And with literal equations, this is how I know my answer is done. Once I get the variable I'm solving for on one side by itself, I am done. So I over PT is equal to R. And why would I want to rearrange this formula? Well, let's say I have several problems that look like this, where I'm given the principal, and I'm given the time, and I'm given the interest, but I don't have the rate. So this formula will be really handy for that. So I want you guys to pause the video here, use this formula to find rate. All right, welcome back. So my interest rate, $362.50 goes in for the I. The principal, the amount of money we borrowed or saved, $2,500. And our time in years is 2. Plug in 2 for the T. Multiply 2,500 times 2 is 5,000. And this would be a good time to use my calculator. 362.5 divided by 5,000 to get 0.0725 as a decimal. And to change that to a percent, I'm talking about 7.25% or 7.25%. And remember, interest rates, banks normally advertise in annual percentage rates, meaning that this is a yearly amount. All right, using the formula distance equals rate times time, or D equals RT, we can solve the formula for R, or we could solve for T. So looking at this one, we have D equals RT solve for R. What's on the same side with the R? Well, the T's on the same side with the R, and is T being added, subtracted, multiplied, or divided? It's being multiplied by to the R. So I want to undo that multiplication with division. So I'm going to divide the right side by T, divide the left side by T, and on the right side, the T's will cancel and get R by itself. So R is equal to distance over time. Let's look at a new problem. We have given 1/2 L. L is a hard variable to use. If you write that, it would make it cursive so you could know it's not a number 1. Equals 10m. Solve for L. Well, anytime I have a fraction in front of a variable, I always get rid of it by multiplying by the reciprocal. So the reciprocal or inverse of 1/2 is 2 over 1. Multiply the left side by 2 or 2 over 1. Multiply the right side by 2 or 2 over 1. On the left side, anytime I multiply the inverse times its reciprocal, I always get 1. So I have 1L or L. And on the right side, 10m times 2 is 20m. So L is equal to 20m. All right, let's look at P equals 2 times B plus H. We are asked to solve for H. All right, so first I want to get that parenthesis part by itself. I want to get rid of that by the parentheses are being multiplied to 2. I'm going to undo multiplying by 2 with dividing both sides by 2. Then the 2's will cancel out and leave the parenthesis part B plus H by itself. Once the parentheses are by themselves, they are redundant. We can remove them and get B plus H. And my last step, solving for h, b is being added to h, so I want to do adding b with subtracting b to both sides. I subtract b on the right side, the b's cancel out, and over here I have p divided by 2 minus b. So h is equal to p over 2 minus b. So let's go through the steps we just did. So we went and literal equations that have parentheses, you want to isolate the parentheses first, and when they're isolated on one side of the equal sign, they can be removed. So let's look at a problem where we do that. We have d times a minus b equals c, and I want to first isolate the parentheses. I want to get rid of this times d, divide both sides by d. The d's will cancel out on the left side, leaving a minus b over cd. And notice how once a minus b is by themselves, I can get rid of the parentheses. Then lastly, to get a by itself, I want to get rid of this minus b. I just add b to both sides. So whenever you have those grouping symbols and you're solving for a variable inside of them, you're going to isolate the grouping symbol to be able to remove the grouping symbol. And then continue solving for the variable. All right, so you guys try this one on your own. Try cx plus 3t equals 2s minus t. Pause the video here. Come back. We'll see how you did. All right, welcome back. So to get the x term by itself, I'd start by subtracting 3t from both sides. And on this side, I have like terms. I have a minus 1t and a minus 3t adds up to negative 4t. This side, the 3t and negative 3t cancel out and leave cx. See how we combine these here on the right side. Then my last step to get x by itself, x is being multiplied to c, so I want to undo multiplying by c with dividing both sides by c. The left side, the c's cancel out and get x by itself. So x would be equal to 2s minus 4t over c. All right, you guys pause the video here, try these three on your own, see how you do. All right, welcome back. So the first one, just to get a by itself, I need to get rid of that minus 7 on that side. I just add 7 to each side, and I have a is equal to b plus 7. On a equals bh, we're solving for h. What's being done to h right now? It's being multiplied to b. So I'm going to undo that multiply by b with dividing both sides by b. So h would be equal to a over b. And on that bottom one, that's where you want to divide both sides by 3 to get the parenthesis part by itself. And our final answer, we would end up with x equals p over 3 minus y. All right, what do some of the harder problems look like? So some of the harder problems with literal equations involve using GCF. So some of the more challenging problems, you'll need to get the variable you are solving for on one side and use the GCF to isolate a single variable. So let's say I have cx equals 3y minus p, and I'm solving for x. Well, I have x in two terms to start with. So first thing I want to do is I want to get all those x's on one side of the equal sign. So I would start with adding px to each side. That has my x term and an x term on the same side. Now I can use GCF. This is where you want to use GCF of x. If I pull a GCF of x out of those first two terms, I get x equals c plus p. This gets me down to a single x term and gets everything else away from it. So with this c plus p in parentheses, c plus p in parentheses times x, I can undo multiplication now, which is dividing both sides by c plus p, and that will isolate the x. So you want to find these when you have the variable you're solving for in multiple terms. You want to get them to one side of the equal sign by itself. So notice how this cx and px, I don't have any other terms on this side when I pull out the GCF. If I did, I would have to add or subtract to get them to the other side. Once I have all the terms with x to one side, that's when I can pull out that GCF, get the x by itself, and then use division to get rid of a whole grouping symbol expression by itself. All right, I hope that helps you guys get started using literal equations, solving formulas for a particular variable. Have a great day. OUT spells out.